Now we're going to look at round-tripping state between the client and the server. The state from the client side can be accessed via server side on the caller property. State on the client side can also be set by a setting on the property of the caller. Here's an example. Here we have the public class of MyHub, which is derived from the hub of SignalR. Within it, we have a public task of send, passing data along, and you can see that we have a string variable of ID equal to caller.id. That is actually loading up the string ID of whatever the ID of the caller object actually is. Below that, we have caller.name equals double quote Bob in double quote. What this is doing is it's actually setting the client side property of caller.name to Bob. So let's look into Visual Studio and see how this is done. In Visual Studio, go ahead and open up your myhub.cs file, and if you are working from the previous example, you'll have this product send here. Let's go ahead and comment that out, and we'll go uncomment our original send method. Okay. So now what we're showing is how to modify the round tripping of the state between the client and server. Basically, because any state that is sent from the client can be accessed via the caller property, which is here. And you can also set the client side state just by setting the property on the caller itself. So here we're actually calling a JavaScript function from the server side, but we can also do other stuff too with that caller ID. We could also say, well, let's get the ID of that. So we could say string ID equals caller.id. So that would give us the ID of the caller. Then we could actually turn around and say caller.name equals Bob. So SignalR is pretty flexible in terms of getting data or setting data to and from the server side and to the client side. So this has been an example of how to deal with the round tripping state between the client and server. Next, we're going to look at detecting connection status using the hubs. Unlike persistent connections, hubs don't have connect, reconnect, or disconnect event. To detect these, we have to use other methods. For disconnects, we need to implement the iDisconnect interface. For connects and reconnects, we have to implement the iConnected interface. This is just because the hubs does not know about reconnect, connect, or disconnect events, much like the persistent connections do. To see how this is done, let's look into Visual Studio. In Visual Studio, go ahead and open up myhub.cs if you don't have it open already. First thing that we're going to do is we need to derive from a few more classes. So iDisconnect is the first one you want, and then we're also going to add iConnected. That's the second one. Let's go ahead and comment out our send. Let's see. Okay. And we will just go to the bottom here and write some new classes here. So first thing we're going to do is we want to track the disconnect. So task disconnect for any time something happens. So we're going to say clients.leave, which is a SignalR, internal SignalR there. Context.connection ID, datetime.now, .toString. So that's saying that it's leaving right now. And we want to return do a clients.add message saying connection context.connection ID has left at datetime now.toString. Cool. Alright, so there's a first task. Next one could be task connect. And we're going to do clients.joined context.connection ID. Also datetime.now.toString. I'm going to go ahead and copy that because that's not going to be the last time we're going to use that. Okay. And let's go ahead and end that line. We're going to say return clients.add message saying connection context.connection ID has joined at. Okay, there's that. And the last one is a reconnect. So public task reconnect. You don't have to use all these if you don't want to, or you don't have to use any of them actually. But these do come in handy when you are trying to track these type of events. So clients.rejoined context.connection ID and our datetime now. And we go return clients.add message connection context.connection ID has rejoined. Great. Okay, so there are our tasks made. We don't have to do anything special over here, except for, since we have these disabled right now, let's disable the send and the join right now. Add message is the only one that we need fully running. So go ahead and hit save and Control F5. Uh-oh. Let's see what I did wrong. Okay, where are we having the error? Center my hub, implement the interface member. Oh, I see what I did wrong. So I got a little ahead of myself here, and I forgot to pass in the IEnumerable. That is what it was complaining about. So it's IEnumerable of a string. That's just our groups we need to pass in. But now, wait, Control F5, it's going to work just fine. Okay, go to hubs, and we see that it's worked right off the bat. Just to prove that I'm not making it up, we'll go ahead and open up Google Chrome, and we'll also open up Internet Explorer, and we'll copy the URL. And as you can see over here in Firefox, both these connections, when they loaded up the page, showed up. So they are working definitely on the OnConnect. So let's go ahead and close Internet Explorer. And now you see the disconnect saying it has a left. And again, we'll close Chrome. And here again, we see that it has a left. So our events are definitely firing between disconnect and connect, and reconnect I'm sure would fire as well. So this is how we detect the connection status within the hubs.